All right. I ask you to take a look and see which of these things is not like the other. All right. If you grew up with Sesame Street, they had a little song or whatever that sang, something like that, or well, no.
Wait, what?
One of these things is not like the other. One of these things just doesn't belong. You have never heard that song?
I don't think so.
I'm old. All right, there you go. All right. So, what do you think?
Graph 2 because it's a linear graph.
Okay, graph 2 because it is straight line, okay? The other 3 graphs have curved lines, so graph 2 doesn't belong because of that, okay? Good. Yes, ma'am.
Graph 4 because it's the only negative.
Graph 4 because it's the only negative one. So this one kind of has a positive slope, that one kind of has a positive slope, this one's upward facing. So there's definitely a negative involved with that one, so that would be a good reason, all right? Very nice? Good? She took yours, huh?
Yeah, she did. I have another
mean,
one.
All right, you got another one, huh? Go for it.
Graph 1 it doesn't cross the x-axis.
Okay. Graph 1 because it has no x-intercepts. That doesn't have an x-intercept. This one has one. This one has a couple. That one has a couple. So it doesn't have any x-intercepts, so it doesn't belong. Yes, sir?
Graph 3 because it has a negative y-intercept.
Okay. So graph 1, 2, and 4 all have a y-intercept at 2. All right. And graph 3 has a y-intercept at -2. So it doesn't belong for that one. Good. Got another one?
I was gonna say for graph 1 because it's something with the exponent, but I forgot how to. It's because it's like the exponent is different.
The exponent's different?
I can't explain it.
Okay. Not doubting it, but a little bit more. Yeah, and maybe you're right. Yes.
I'd say graph 4 because it's the only one going down and not up.
Okay. Got you. It's the only one going down as we go from left to right. Anybody else? All right. That's good. So this is a good little thinking activity. All right. We've got a lot of little things that we're talking about. We're talking about quadratics. We're talking about linears. We're talking about exponentials. And there's a lot of times that you might have the right answer. You may see something differently, but you just need to be able to justify and explain what's going on. All right. Let's turn to page 29. I had a little activity for you, but for some reason the link's not working. I'm going to try to get it working tomorrow. That way we can look at that activity. All right, but for right now, we're going to handle a couple of problems here. So I want you to read page 29. And I want you to work question 1. All right, read page 29. And I want you to see if you can draw me a couple little scenarios on that one. No, just read them. All right, you're drawing some rectangles right now is what I need you doing.
It's my form of rehab. Figure out how much it's on four sides.
Did your mom get that for you?
Actually, for that was it.
The texture is like that is not a rectangle, Lillian.
All right.
That's a square.
So,
You're so dumb.
We'll talk
You
about that
wrote
in a
the same measurements.
all right. We have a farmer. He's building a fence around his. He's building a rectangular pen, all right, to fence the animals in, but doesn't want to crowd them in too much. Wants to make as big of a pen as possible. So somebody give me one of the pens that you were able to come up with that we could draw. What are the dimensions?
1,000, 1,200.
Okay. So I could go 1,000, 1,000, 200, and 200. And again, what do we know about all four of those numbers?
They add up to 24.
They add up to 2,400. So there's an example there. That'd be one we could add. All right. Somebody give me a different one.
800, 800, 400, 400.
Okay. So I've got 800, 800, and 400, and 400. Okay. Somebody else.
1,000, 100, and 100. Like,
Okay, you did 1,100 and 100. All right. You must not like those animals too much. You're gonna make them run a really long dog run thing. All right. Have that there. All right. Now, is that the only ones we could have come up with? No, there's lots, right? And so we'll talk about some more here in a minute as we're going. So we have that. And now on the second part of this, it asked me to build a table with these kind of ideas. All right. So now I'm going to build a table. It says create a 3-column table with width and length and area. All right. So I'm creating a 3-column table. The first one that we said just a second ago, all right, was 1,000 and 200 and how do I get the area? We're going to multiply length times width together. That's correct. So that would be 200,000. Okay? The second one that we came up with a while ago was 800 and 400, which if we multiply those together, 8 times 4 is 32 with 4 zeros. Okay? And then we had another one, 1,100. Sorry, I put one too many zeros. 1,100, 100. And so that would be 1, 1. There'd be that one. Okay? Now, let me get a little bit more data from you before we continue. Okay? I picked those 3 a while ago, but anybody else have another rectangle that I don't have up here? Yes, sir?
700 and 500.
Okay, 700 and 500. So 700 and 500, all right? And that would be 35 with 4 zeros. Now, anybody else? 600, 600.
But I thought I'd get a rectangle though.
Okay? But it has to be a rectangle. Now, let me ask a question. Is a square a rectangle?
Yes.
Yes. Is a rectangle a square?
No.
No. All right. So what's the difference? What's the definition of a rectangle? Geometry, right?
How? I don't know that.
4 sides. It is a quadrilateral. There's 90-degree angles for all the rectangle. These 2 sides right here are the same, and these 2 sides here are the same. They're parallel, and that's that. So that's the definition of a rectangle. That these sides have to be parallel and the same length. These sides have to be the parallel and the same length or width. Okay? Well, what's a square? Are these 2 sides the same length and width and parallel?
Yeah.
Are those 2 sides the same length and parallel?
Yeah.
Yes. So therefore, a square is a rectangle. It meets that thing. But why is a rectangle not a square? What's the definition of square? All sides are equal, right? So that's why a rectangle is not always a square. And so when I multiply that together, I have this. Now, what is my goal in this problem? What did it say in the instructions at the top? To find the maximum area. All right? Well, if we stopped right now, what would you choose? The 600, 600 would be the maximum that we see right now, correct? It's got the biggest area that we see. Now, we want to write an equation with this. All right? And so it says be ready to share your values with the class. We've kind of already done that. But I'm going to write an equation in that little spot in your notes. Okay? What's the formula that connects all this together? You've already told me once, but what is that formula? Length times width equals area. Somebody said that. So length times width equals my area. Now, as I kind of look at this, there is a connection here. And you're probably thinking about it. You just may not have verbalized it or written it down. All right? How are all those values connected?
I think they're connected by like the closer the length and width is, the higher the area is.
Okay, the closer the length and width is the bigger the area. That's a good connection. Good. I was even asking for something even simpler than that.
They're all even.
They're what?
All even.
They're all even? Yeah, could we have gotten some odd ones if we wanted to? We could have picked some odd ones. What do we notice about each pair of numbers? They all equal 1,200. All right? They all equal 1,200. So I could keep going through here and finding pairs. And if you tell me what the width, I'm going to tell you the length by subtracting it from 1,200. And so could I say this? If I have the width and the length would be 1,200 minus width.
What?
Is that true? Okay. I'm getting the length by saying 1,200 minus whatever you tell me the width is. That's what I'm doing every time. All right. So if you give me 1,000, I'm going to go 1,200 minus 1,000. That's 200. Okay. Or if you give me 800, I'm going to go 1,200 minus 800 is 400. All right. And so I can write it like this also. Well, the nice thing about the blue versus the purple, how many variables do I have in the blue? Just two. I got an area and I got a width, right? How many do I have in the purple? I've got 3. That's harder to decide. That's harder to figure. All right. Now, many of you don't like the way that the blue is written. How could I rewrite that? Could I distribute? So 1,200 W minus W times W is W squared. All right. What type of model is that now? Not exponential. That is quadratic. It is quadratic. And so it's hard to see that in the blue that it's quadratic. But when I write it in the red, it looks quadratic. Now, some of you go, well, I don't like the W squared last. I might rearrange, and that's fine. You might say negative W squared plus 1,200 W is equal to 8. That would work. Okay. Now, next, when we turn the page, all right, page 30, all right. So if I turn to page 30 here, it asks me to use Desmos to determine a quadratic regression equation in standard form for this situation. All right. So let's go to our Desmos. All right. So take your Chromebooks, and I'm going to go open Desmos. I'm going to go do a graphing calculator. Okay. Yep. All right. So when I go to Desmos, I'm going to go build a table. All right. Now, here's the hard thing. We built the table already, correct? Except it had 3 columns in it. We only want 2 columns. Which 2 columns are we going to put in here? Say again? Not length and width. Because what's my goal? That's close. I want to find area. So I need to have area as part of it. All right? You could use length or width. I don't care for the other one. But that's going to be the first column. And the area is going to be the second column. So the first one that was given to me was 1,000. And then the area we found was 200,000. All right? The next one we said was what, 800? 320,000. Okay. We had an 1,100. And that was 1, 4 zeros. We had a 700. Well, it's 3, 5, 0. And then we had a 600. Now, by the way, you don't need this many data points. It's not too bad. It's about 6 data points. That's not awful, all right? But you could actually probably get by with just 3 of them. That's why they asked me to do 3 at the very beginning, all right? But we're just kind of sharing our data. Unfortunately, I can't see this because these are some pretty good sized numbers. And so I'm going to go in and hit my zoom fit. All right. Now, let's talk about it real quick. What model looks like it fits good here? Does a linear model look like it fits well?
No.
Not really. All right. How about exponential? Not really. Exponentials normally go up or they work down this way. This is a little bit different. I'm going to show you something in a second that I kind of match that. And so it doesn't look exponential either. And so the other one that we've been talking about, or that we've just discussed, is quadratic. So let's do this real quick. I'm going to go up here, and I'm going to click the little regression. And the first thing it's going to do is it's going to put the linear regression in for me. It just always starts there. Okay? All right. Now, let's go in and plot the residuals. So if I hit plot, plots the residuals. All right. Obviously, just with a visual inspection, it doesn't look very linear. All right? Tell me about the residuals. They look quadratic. They look like a pattern. Good. All right? They look like a pattern, so we'd say it's probably not a good fit because my residuals make a pattern. All right? The next thing that we've been talking about is we could say, okay, let's go do an exponential regression. If I do exponential, then this is what I get. All right? That doesn't look really any better at all than the linear. And again, if you notice the residuals, they look farther off, and they still look like they're in a pattern. All right? Now, I'm just going to touch on this just real quick. If I click here, and I go take a look at a logarithmic regression, all right? Just want you to see it. Actually, that one didn't do it, did it? All right? I think it's because of the nature and what it is. Sometimes that will actually fix it and put that in as well. But it didn't do it either. So if I go look at quadratic now, if I go look at quadratic regression, I get this here. What do you notice? It's what?
Perfect.
It's a perfect fit. That's correct. It is a perfect fit because all my residuals are horizontal and they're all on that x-axis. So it's a perfect fit. So it gave me the equation. Y equals negative x squared plus 1200x plus 0. Does that look familiar? Was that the same equation we just wrote?
Yeah.
Do we need the plus 0? No, not really. All right. Now, we wrote that other one by hand, but in this one, we see it here as well. All right. So y equals negative x squared plus 1200x. It asks how is this similar or different from the function that we just wrote together? Well, it's the same one, correct? This is standard form. That's standard form for the quadratic. If I go back to page 29, down here that we wrote, this we refer to as root form. Okay? So we basically have the same thing. We just have it in two different forms. We have a root form and we have a standard form. Okay? Now, I'm going to go back to page 30. On page 30, it asks me a second question. How can you use the regression and its graph to determine the dimensions of the animal pen with the greatest area using available fencing? So how can we use that graph to help us solve what's going on? We want to find what? The vertex. We want to find the vertex. We want to find the maximum. Yes. So we were saying, so if I were looking here, that looks like it's the max right there. If I were to click on it, it tells me what that point is. And so 600 is the width. 600 is also the length. All right? Because that was that square one. And my area is 360,000 is what it is. Okay? And so if I was going to build this fence for my animal, I would build it 600 by 600. Which would give me an area of 360,000. And many of you said this a while ago, we're going to find the vertex. All right? Going to find the vertex, which in this case is the maximum piece, or the next maximum point. All right, everybody okay so far on that? Let's keep going. All right. Question 3, same page. Question 3 says use Desmos to find a regression equation in vertex form of the data set. All right. The Desmos command for determining this vertex form. So when I have it written like this is the vertex form. When it's written like this, H and K is my vertex. Okay? H and K is my vertex when I have it written like that. Now, and then ask me how is it similar and how is it different than what we wrote earlier. All right? So the only bad thing about this is when I go through my drop-down menu right here, it asks me which form, but they're already in a predetermined form for me. They're all in standard form. All right? But it's asking me to write it in a different form. So in order to do this, I'm going to have to customize this myself. All right? So I'm going to hit plus sign, and I'm going to hit expression. And I'm going to type in what is on the page there for me. So I'm going to type Y1. So that's what I'm just going to type on my Chromebook. Y1. Now, if you notice on the other page, it has not an equal sign. It's got this little squiggle line, this little tilde. All right? And so I'm going to use that. Whenever I use that little squiggle, it's asking me to go find the regression. That's how I'm telling Desmos to find the regression. Now, where is that? Well, if I use my little keyboard down here, actually, you probably could do it on your home keyboard there, but it's in the alphabetical part here, and it's right below the B. All right? That's where that is. Now, I'm going to finish typing the rest of it. It's A. Then we're going to type in a parenthesis. X minus, I'm going to put an H. I'm going to close my parenthesis. I'm going to square it. And then I'm going to go plus K. All right? Now, yeah, I pushed the button. I pushed this button right here to get the square on it. Okay? Now, it's not going to find the answer right now because I left one thing off. I left off X1. I have to tell it not just X and Y, but I have to tell it which X's and which Y's. And I'm using the table that we created a while ago already. Okay? So I need to go back to there and I need to say X1. Then it will go find this for me. Okay? Now, it says, when I do this, it says, okay, the regression, A is -1, so there's a -1 there. H is 600 and K is 360,000. Well, what was 600 and 360,000 from a while ago? That was my vertex. That was my answer. That was my vertex a while ago. Well, now that I have it in vertex form, those numbers show up in the equation. All right? So, my vertex form would be y equals -1 x minus 600 squared plus 360,000. Okay? Now, if I have it written like that, it's kind of nice because I get my vertex really easy. There's my width, and there's my area. And so I know exactly how, I'm finding the same answer, it just looks different. That's all I'm doing. Okay? So we've kind of got the answer to question 4 already. All right?
Excuse me,
Yes.
yeah, Victoria,
Okay.
being checked out.
All right. All right, so let's do this. Let's try another one of these. All right. Any questions about what we've done here so far? All right. So let's go here. Now I'm going to save you a little bit of time. So if you'll go to Schoology real quick, I put this data into Schoology for you. Okay. All right. So go to Schoology, and the fuel efficiency link that you have there. All right, go here. I'm going to go to my Schoology account. I'm going to click on my fuel efficiency. And I'm going to take that out and put it over here. Okay? All right. So I'm trying to help speed things along a little bit for you. All right? So what I'd like for you to do is I would like for you to go answer question 1. You might want to read the top to know what this problem's about, but you have the data here. I want you to read question 1 and answer question 1 for me. All right. What is this problem about? Miles per gallon of fuel compared with what? The speed at which I'm driving. All right. The speed at which I'm driving and the miles per gallon of the fuel. All right. This is making mention in the late 1990s. All right. And there was a lot of speed limits that were very high, and then all of a sudden, this little report came out, and like all the speed limits went to 55 miles an hour, like everywhere, like highways and stuff. That was the maximum speed for a lot of places you were going. All right, a lot of people did not like that. All right, because they couldn't get where they wanted to go very fast. All right, and so if I'm looking at my data here, it asks me. Provide one reason why this is quadratic and why you think it, and the reason why you think it's not quadratic. So, thoughts? Why do you think it's quadratic? Why do you think it's not quadratic?
It curves down.
Okay? It curves downward. It's got a little dip in it, kind of curves down. All right? That's a little concerning. All right? So that would probably be a reason why I don't like that, because it's a little dip in it. All right? Is there a reason that you do like it for a quadratic?
It kind of has like the same downward.
Kind of goes up and then goes down, like just big picture.
Yeah.
It goes up and then it goes down, which is kind of quadratic in nature. Now the little dip in it does kind of bother me a little bit, but overall, big picture looks pretty good. Any other thoughts about that? All right. Now, what could we do to check? We'll look at it here in a minute. Actually, it says this. Go find the regression. So this ought to be pretty easy. I'm going to click on this, and it writes me that regression. I don't want linear regression. I want quadratic regression. So if I were to go write this in my notes, that is question 2. Question 2, determine a quadratic. Y equals negative 0.008. Is that right? Yep. X squared plus 0.7396x plus 1603. All right? So I've written the equation. It told me the equation. I'm writing the equation. All right? Could I have written it in a vertex form if I'd like? Yeah, I just have to type it in, right? Sometimes I'm lazy. I like the way that they have this. Hopefully the next little update on here will allow me to write it in different forms. That would be cool. Okay? Now, it asked me to find the residual plot and to analyze it and to see if you think this is a good model or not. So I'm going to go down here and plot it. Okay? Thoughts? Good model or not a good model? Not? It's not too far off, correct? What's the one thing that is concerning? It's got a wave pattern, correct? It's got a little pattern in this. It's not just random. It's not a nice horizontal line. It's not too far off, but the pattern here does really concern me, okay? And so because of that pattern, I would probably say not appropriate, okay? All right? And so on this, I'd probably say not appropriate. Probably say it's not appropriate because of the wave pattern that I see. All right. So if we were going to use this regression and we were going to find the maximum value, the most efficient, what would you say would be the most efficient one on here? By the way, do you notice it? They put a dot on there for me. They put the dot on there, that's my vertex. So what's my vertex telling me about this problem? I need to drive 45 miles an hour. If I drive 45 miles an hour, I'm going to get 32.5 miles per gallon. Okay? In this car, whatever this car is. Okay? So 45 would be optimal. All right? Which is actually pretty true a lot of times. I've kind of charted my own truck a few times, did that. So 45 miles an hour is the maximum value, and it's paired with 35.2, which is the gallons. So if you wanted to conserve your gas, that would be a good way to do that. Now, if this is the data set that the FHA used to estimate the most fuel efficient speed for driving, a typical mid-sized car is 55 miles an hour, how might they have come up with that conclusion? Because that's not the conclusion we got running the quadratic regression. How might they have come up with the conclusion that set the mile per hour at 55? Thoughts? Why did they set the speed limit at 55 miles an hour?
To make it go fast.
To make you go fast?
Yeah.
What data can we look at? What's the data say? Okay, if I run the regression, it says 45 miles an hour. If I just look at the table, though, what do you notice?
It's the same as 50.
Okay, 50 and 55 were the same. It was 32.4. And those were the highest two values in the table. So if I could set the speed limit going 55 versus 50, why not, right? Let's go a little faster. We're going to get the same mile per hour. We'll get there quicker. And they probably set it at 55 due to that. All right? Make sense? So something along those lines. All right. Last thing, let's go to page 33. All right. On page 33, I want you to do questions A and B. All right? Page 33, do questions A and B. All right? We've got about 4 or 5 minutes. Would you put 2010 in here?
No, you put.
We could put 10 or we could put 0, either one. All right? And so I could put 10, I could put 11, I could put 12. Those would definitely be a lot easier than the other. All right? So on page 33, I want you to do questions 1 and 2, or A and B. All right? And that's where we'll finish for the day.